Hello and welcome to another video at Indies Tech. Today's video is on MATLAB image processing tutorials. I have made some previous videos, so in this video I have incorporated those videos for ease of access. Now, the start of this video I gave a brief background of MATLAB, what it is used for, and its creation. The whole background then incorporated with the topic. Following topic has been discussed. MATLAB tutorial for beginners, then image color channel separation, edge detection, signal to noise ratio, histogram equalization with Excel and MATLAB, Raspberry Pi 4 night vision project with MATLAB, then camera object tracking with MATLAB, and lastly VRAP smart robot simulation with Raspberry Pi and MATLAB software. All of them are image processing topics with lots of tips and tricks and techniques. The uses of MATLAB are the following: numerical computation, data analysis, visualization with algorithm developments, engineering and scientific application, in the field of education, integration with other programming language, industry and research, product development. Clive Moore, American scientist and academic, invented MATLAB back in 1960s during his PhD thesis, and on the left is the headquarters of MATLAB in United States. The computational requirement for MATLABs are the following. Processor, it is recommended to get 4 core plus. 16 GB RAM is recommended, but all of my project has been done in 8 GB RAM. 20 to 30 GB disk space is recommended. Graphics should be OpenGL 4.5 plus with SSD storage. Now this table gives the operating system a specific background of the computational requirement for MATLAB. So as you can see, these are all same and there is not much different from the previous slide. The prices of MATLAB is for individual license is 800 GBP per year. The price of MATLAB for a standard license, it costs you £800 per year. Then it starts, the most expensive one is the startup version of it, which is £3,250 here in United Kingdom. Academic versions are £228, but the license can be shared with the student free of charge, whereas the student version itself costs only 59 GBP, but it can be a free trial version free of charge for less than a month. The home edition can cost £105. The best place to learn MATLAB is not from my video or from YouTube. The best place to learn for any technical topic is from the manufacturer's website. Here in MATLAB help section you will get the detailed description of all the libraries, but of course the YouTube videos or the technical help from other sources can be helpful. Now, without further ado, let's get started with the tutorial. Just to be sure, Next, the tutorial will be on following topic with the, I will start from next, the tutorial. Next, the tutorial will be on following topic. I will start with beginner level project, then slowly progress to more technical like edge detection, RGB edge detection, image color channel separation, noise removal, image signal to noise ratio. Then we'll progress on histogram equalization and contrast stretching with image histogram equalization with Excel and MATLAB, then 3 of the Raspberry Pi 4 project. The last one is on VRAP robot simulation with OpenCV and MATLAB. Now let's get started. Hello, welcome to another video of Indis Education. In this video, I will discuss MATLAB basic image processing techniques, including opening an image file in MATLAB, converting to grayscale image, separate the image RGB color components. Now let's discuss how computer vision works. Human can understand the semantic meaning of an image. On the other hand, computer see only digital representation of an image, i.e. by looking at a cat image, human mind process the vision data as a cat. But for the same image, computer only see pixels in simple explanation 0 and 1. In this background image, human sees the reflected lights and process the information as a canal and footpath. On the other hand, computer sees the different intensity pixels segmentations laying in different ways. Now let's get familiarized with the MATLAB work window. There are 3 parts we mainly need to concern of. The first one is the current folder. Here you can see I marked it on the right, the current folder, then the command window, and then the workspace. When you first open any MATLAB the software, you see these 3 windows. So the current folder is the which folder we will be working on, and the command window is where we test our codes. It's basically is like a rough notebook, but whenever we implement any script, it goes through the command window, and whatever goes through the command window, either it is an input or output, it is always assigned at the workspace. The workspace is on the right, so the x and y in this variable. Now in our code, to assign the current folder, we can use this line of code. So if we just write pwd current folder, which will show that which current folder we currently have, then so just try it. If I run this code, it goes through the command window, the same bigger command window I showed you previously. In this time I have opened the script actually. So the command window is showing that current folder is C, the tutorial, and the MATLAB first image tutorial. We can change the file path, whatever we will be working on. These 2 lines of code I just commented. If we just take out of the comment and implement it, basically I wrote the same file path, whatever is currently assigned on. So if I run the code, it changed the whatever the current file path it was, then it shows the new current path with the current folder and pwd. Now how to open the first script? If we can just see the window, if we can just click new, then click the script. There are a few kind of script. One is script, the normal script, and one is the live script. At first, in this stage, I would recommend to use the normal script, the one at the top. So if you click the script, here you go. It just came with the previous window I have just shown previously. So in this window, if you write the code, your first code would be B equal 3, C equal A plus B. So this is a simple line of code, and if we run this code, it shows in the command window the C equal 5. So A we defined it. A is a variable, A equal 2, B equal 3, and C equal A plus B. Now this part of the code, I will open a pre-made file just to keep things in short. So this file is located on the same folder path I have provided. So this is the image processing fast tutorial MLX. If you can just click this file, it will open up itself with the whole script of codes. So this is the definition. So this is the letter I define the whole code. I define in a variable. So when you say what is a variable equal I am read this file path actually indicating this image llama.png. Llama.png is here. So I am read the full file path. It's located in user desktop MATLAB fast image tutorial llama.png. I assign a title. This is the code for title. So for the any image, we just need to write title. This word can't be changed. But this is the image. This is the name. You can assign any name you wish. So this is the full image name. If you can just if we edit this thing, we take the E off. As you can see, if I run this code, so the now the next part is converting the image to grayscale. The command for this is RGB to gray. This word can't be changed, but these are the variables. You can write any name you wish. The A indicate the first picture, first image. So this is the variable. We define the whole thing as A. So this is color image, RGB image, and converting to grayscale. So A grayscale from RGB. Then this code I am sure B. So this is the result of grayscale conversion. Now the next part is separating the image in red, green and blue color component. So the first code is the C variable equal A. A is the main image, main color image. This is the A main color image. We're converting to red. That is the code for red conversion. So we wrote like 1. If we make it 2, means green, and 3 is blue. Then I am sure C. So the red component, red color component conversion is showing here. So this is red component of llama image. As I have already included the color patch here, this patch, as you can see in the main image, it has got the red component, green component and blue component. When the color separation happen, if it is only red, so the red will light on, it will be white and other will be black. So we can see in the red color conversion, it has light up and the other two color has been marked as black. Whereas in the grayscale image, there are some intensity, different intensity level, the color is there. Now the green color component conversion happened here. So the green is on and 2 is dark. The code is that. This is the same code as we used in previous line as this code, but we wrote here instead of 1, we wrote 2. Now in this part we have done the blue color conversion. So this is the same line code as we wrote previously. So just instead of 2, it's 3. Remember 3 is blue, 2 is green, 1 is red. Now we have converted the whole image to binary image. Binary image is just 0 and 1. With this command, there is a threshold implementation. If the color goes beyond that threshold, it convert to 1, which is black, and if it is below the threshold, it becomes 0. So this is 0 and 1 only. In this level, this image pixel has got nothing to do with the color image. It has got pure black and white, which is 0 and 1. Now this command figure subplotting all the images we have created earlier in one image. With this code, this numbers 3 means the row of the figure, 2 is the column, and 1 is the index number. So for the first image is 3 row 2 column, where the image will be in index 1. So it is index 1. The second image is the grayscale image. It will be index 2. Third image, the red image, is index 3. Then index 4 is the green image, and index 5 is the blue image. Now if we can just try some other files I have already included. If we can just change the name llama png to this file rb.jpg, just write rb. If we can run the code, rb.jpg. So jpg, we can run this code. The same code format shows like this. So this is the main image with we open the same file, same code. We open the file with the same code and red, green and blue color component, then the grayscale image, then the red component of the image with this code, then the blue component, green component of the image with the number 2, and this number 3 with the blue component of the image. Now the whole thing in binaries, it shows like this because there was no white color. It was pure color, red, green, and blue. So the thresholding happened to be chosen for everything 1. It is more than the threshold assigned. Then in the same figure command, we can see the images like this. Now next bit, we try another image. So if we can just change the name RB, we need to assign this this image name, which is mji.png. This image we need to assign, so it will be mji.png. If we run the code, so we see the code, the red color component, the green color component, and blue color component. Bear in mind that these components are not pure red. There is always some noise in it. How it goes with our code: this is the grayscale, this is the red component, remember, with 1. This is the blue component with 2, and this is the blue component with 3, and this is 2 for the green component. And the binary image looks like this because you can see that there is some pure white and there is not very pure black, because there was some noise present in our image file. It was never pure black or pure white, as you can see from the main image. It was never pure black or pure white. So the binary conversion happened to be like this, and then we show the whole conversion process in one figure. Thank you for watching. Hello and welcome to another presentation of Engis Education. In this presentation, I'm going to talk about different MATLAB operational parameters which you really need to be careful. It can hold you back at the beginning. So the first thing is that you check the version, which version of MATLAB you are using, and you document it properly, you memorize it properly. The reason is because if you go to another computer and if you use the different version of software to open the advanced version software, it would not work. For instance, currently if you're working in 2019 version software and if you go to another computer and try to open that file you generated with 2019 version, this file would not work. So make sure you check which version of MATLAB software you are using. So the best way to check is the top right, top left corner of the window. You see the version. Usually it is assigned as R20. If it is a 2019 version, it would be R2019A or 19B. If it is 2018 version, it would say R2018A or B. Same goes as the year goes. So for the 2015 version, it will be R2015A. So be careful about this. The next thing I'm going to talk about check the working directory. The program need to know from where the file are sourced. So there is a default file location, as you can see on the image, is in C program data memory in MATLAB programming directory, but you need to assign it which directory you really want to be. For instance, in this file, if you download the link provided and try to execute the code, you're basically trying to open an image file, but the image file is located in some different places. So if the image file is located in different places and you're trying to open that file which is not located where your program knows where it is, it would not work. So make sure you give the right file path. Now the next important thing is that you don't write your code in the command window. You know, at the bottom of the MATLAB window there is command window. So this place is basically is the rough notebook. This is for your practice. You practice your code. 2 plus 2 equal 4. You practice this kind of thing which you think is might work, so you just practice it there before writing it to the proper place. So this is called command window. So the command window, this is not for storing any code. It has no write your code in the editor window. You can see the editor window on your screen. Editor window is basically is the place where you should write your. Here you can see on the image, I basically opened the editor window. Once I have downloaded my file from the link provided, the file is in GIF format. So basically you download the file from the link provided, then you extract the file. When you extract the file, you open the file, and you on the top of the file path you click it and copy the file path. When you copy the file path, you come back to the MATLAB window. You come back at the MATLAB window and paste that file path, so the program would know from where it should look for the executable files. If you want to open an image, so the image content on that file, so MATLAB know where to look at, it will open that image. If you put the wrong file path, the MATLAB file would not find the file it try to open, then it could not open anything, so it would give an error. Find the file. The next thing is you should keep the patience, because you know the MATLAB is a very high level language which takes time for the code to execute. So in this code, if you see, it's just opening a simple image. If you want to open this code and if you press the run button to come to this point, it takes about 7 seconds. So you appreciate that it takes 7 seconds. And finally, viewers, as you can see, I'm new at YouTube and I need your help. So if you like this video, please like and share and subscribe. That would help me to achieve my goal. Thank you very much. Thanks for watching. Hello and welcome to another tutorials of Indies Education. In this tutorial, I'm going to discuss MATLAB age detection algorithms. Now let's do some recap from last week. I discussed previously about few fundamental things which is really important for the beginners to practice. If you can avoid these mistakes, you can really short your learning curve and move forward. So the first one is check the version of MATLAB you are using. Like my one, I'm using MATLAB 2019. So this file you can download from the link provided, will not work in 2018 version. The next one is know where your file is located, so make sure you put the right file path on the working directory. The third one is don't write your code in command window, and the fourth one is write your code in program editor. And the fifth one is be patient. MATLAB is not a very fast language, so it takes time for the code to be executed. Okay, let's open a new file. New scripts, live script. I'm going to open the live script. When you open the live script, give it a name. So text, heading, title. Now let's start the code. So the code button, give it a variable name a equal open an image file. So the command is imread parenthesis
apostrophe the name. So I'm going to open this image file yahoo.png. so top png semicolon. Now I will convert this image to grayscale image. The command is RGB to gray, RGB to gray. As you can see, it's been highlighting there, so just click it. So which file I want to convert to grayscale? This a variable. So a, which is the yahoo.png image assigned for, again semicolon. Now I want to open both the file in side by side so that I can compare. So subplot that will be in 1 row 2 column. So bracket 1 row 2 column, and the image number I want to get is the first one, so image number will be 1, comma imshow a, give it a title name, title color image, semicolon, then another image. I will just copy the whole line, copy, changing the variable. Everything is same, but this time I want the image to be the second one, so just changing to 2, and the variable is b, the grayscale image. B, title, changing the title grayscale. Grayscale image. Now let's run the code. Okay, you can see side by side my image is color image and grayscale image. So this is a figure, 1 row 2 column. That's how you would write. Now let's talk about the age detection. First, let's discuss what is. So if you go to Google, so if you go to Microsoft Edge, just write what is image age detection. So you get the Wikipedia page. So let's go to MATLAB. So the age detection is basically locating the boundaries of desired object in another fundamental aspect of image processing. So locating the boundary of the image age. So this is the image. This image shown here is a 120 by 120 pixel image. So it has got 120 column and 120 rows. The age is detected. Basically the boundary of the image has been detected. Now how are you gonna apply this boundary? I would write IM tool B So just run the section of the code. Here I can see my image. Now in this image, if you hover your cursor, you see the image is 255 by 255 8-bit image. It has got 255 rows and 255 columns. So as you can hover your cursor, you can see here is a block. So the block, it has got the pixel number is showing, it is 63 row and 30 column pixel, and it is 0. This one, as you can see, this is 155 row and 18 column pixel. No, basically this is 155 column, 18 row pixel. This one you can see is 47 column and 26 row pixel. Again, the pixel value is 0. How about the white one? Here, if you put the Y button, which is white color, you can see the pixel number is 80 column, 109 row pixel, and the pixel value is 255. So the white is 255 and black is 0. So this is the pixel value. So we need to change the edge will be detected, the change in boundaries. So the boundary change happen here, this circle button, the boundary change here, the boundary change happen in the Y, the boundary change, different boundary change happen here. So what is the difference between the white color Y and this smiley emoji button? You can see the pixel number is 122 edge column and 149 row. The pixel value is 232. You can see it properly. The pixel value is 232. As you can go to the eye of the smiley face, if you can hover here, so it is black, but as it is not proper black, so the pixel value is 97. In this way, so basically the program in the background, the following edge detection command I will be using, they will be changing, they will be detecting this change in the pixel value, and they will visualize it. So let's go back to our code. So there are different kind of edge detection. First I will use the Sobel edge detection. So Sobel, I'll go the variable name I give is C equal edge bracket B comma apostrophe. The name of the command is, as you can see, there are different Sobel, pre-wit, Robert, log, zero cross, Kenny. So basically you write any of the name. These are the main edge detection technique. So I write, let's write the Sobel, this name Sobel, S-O-B-E-L, capital S. Semicolon. Now let's open the whole thing in one figure with the black and white and grayscale. So the change it to 1 row 3 column. So 1 row 3 column. Copy this line, so change to column number 3. Our edge detected image will be located. So the column number 3 this time is C C, title, Sobel image. Let's run the code. Here you can see the three image has been published side by side. So the color image, grayscale image, Sobel image. In Sobel image, so the age is detected, is basically detected the change in the pixel values. So from here the black pixel value, which previously we have seen is 0, and different pixel value is more than 0, close to 255. As this place is not proper, is there is little bit white, I would assume it would be 100 or something, what value it is. So if I take the IM tool, so this is the picture. So if I go here, is the white 255, 97. This pixel here is 216. This pixel little bit black is 102. So that's how the age is detected, and the command I have already shown you. Now let's go little bit further. What actually happened background of this code generation? Again, go back and we can, if we just search it online, if we just search the Sobel age detection, go there, as you can see, what really happened at the background is that there are two kinds of Sobel edge detection. One is horizontal edge detection and one is vertical edge detection. What basically they do is that, for instance, think about this image pixel as the A1, this pixel here, the image has been shown here, which I think is a Vietnam War picture. So this pixel number M go to the center point of the kernel, and this top left get multiplied by this number -1, middle left is multiplied by -2, and the bottom left is multiplied by -1. Same goes for the top right, multiply top right, this pixel is multiplied by 1, this pixel is multiplied by 2, and this pixel is multiplied by 1 again. The middle is multiplied by 0, and this process is carried out to all the pixels, all these pixels. How about when the center pixel is there? So this is center pixel, this value here is out of the image, so it is considered as 0. So if it goes out of the frame, it is considered as 0. So there are two kind of multiplication went through two kernel. One is horizontal kernel matrix, one is vertical kernel matrix, and that give us this code. Now let's try another edge detection technique. So basically just copy this line of code, change the name to D, same goes the age, detecting the age of the B, the grayscale image, just changing the name, pre-width, I get the name from the list, so this is the pre-width. Pre-width edge detection. So here I would just change the value to one row 4 column, my pixel will be 4, changing all this, 1 row 4 column, 1 row 4 column, 1 row 4 column. If I run it now, changing the name, I'm sure D, preview it image. Let's run it. So as you can see, I've got my 4 picture side by side. So this is preview image, Sobol image, grayscale image, color image. Let's just see one image at a time. So I will just say I am sure D is the preview image. I'm sure D. Let's run the code. Let's deactivate all the lines at the top, so that way we can deactivate all the lines. Just leave these lines, select all the lines which we want to deactivate, right click, put command button. The code will consider this line as comment, not code. This line need to be deactivated as well. This way of commenting is quite effective because you can use it for debugging to fault finding. You can use it for fault finding in the code. So if you run, if I just run the code now, here is my preview edge detection. If I deactivate this line, comment, and no, let's keep it here. I want to show the Kenny edge detection. I want to show the Sobol edge detection we have carried out previously, but in the array format where all the image was shown in one figure. So this time I am sure C. So this is the Kenny edge detection. Now I want to compare between Sobol and preview. So I'll do a subplot, copy, paste, subplot, one row, 2 column. Number 1, I want to show the Sobol image. C is the Sobol image as we previously assigned it. Title, Sobol image. The next one as it is, subplot, paste, just changing the number of the column. So number 2, preview image. If I just run it now, let's deactivate this line as well. So comment it. If we just run it now, well, this one need to be changed to. So as you can see, this is my Sobol edge detection, this is my pre-weight edge detection. Again, what is pre-weight edge detection? Pre-weight edge detection can be found, just Google it. Pre-weight edge detection image. So the pre-weight goes same like the Sobol, but the kernel is different, the multiplication matrix is different. So this is the multiplication matrix or mask. So this is the horizontal mask, this is the vertical mask. So the horizontal mask is, as you can see, this website. Let's click it. So edge detection. So basically the pixel value is multiplied. So if I open my image, so think about this pixel value, which is the pixel at the left or top left corner. The pixel number is pixel location is 29 in x direction and 23 in y direction, x direction, y direction, 18, 34, 27, and the pixel value is 0. So if you multiply the 0 pixel, so the 0 will be the center one, and all of the neighboring pixel will be multiplied by the following numbers, following pixels. How about the white one? The white one is pixel number 93x 122y. The pixel number is 255. So this pixel will be multiplied by 255 times 0, and the neighboring pixel, which is 110, will be multiplied by this 0. How about the left side pixel? Left side pixel, consider this pixel value is 96, will be multiplied by 0. How about the top pixel? The top pixel is 185, will be multiplied by -1. Top center pixel 180 multiplied by -1. So this way the Sobol, this way the pre-weight edge detection is generated in MATLAB code. Again, all these things happen at the background. We just write the name and the program would do it. So let's open another edge detection line. We give another variable e equal edge bracket b, the grayscale image we have already assigned RGB to gray. So the b, I want to open it as canny edge detection. So b comma apostrophe c a double n y canny edge detection semicolon. This time let's just open this canny edge detection picture first, then we will compare it. So if we just copy it, copy and paste, changing the name, comment all this, comment, deactivating all this, run. So this is my canny edge detection. Let's compare 3 edge detection, Sobol, pre-weight and canny at same figure. So again we will do subplot. Let's deactivate this line. but it will change because I have got 3 image, but in this configuration only possible to show 2 image because it has got 1 row 2 column. So how about we increase 1 column 3 column, copy this code. As you can see, I'm trying to copy and paste the code I have already created. The reason behind is that I want to make you a habit of modular programming, where you make one module, then you reuse this module to make another line of code. So this time is column 3. The variable is not D, it is E, this variable. E, title Kenny image, change the title, Kenny image. So if I run the code now, basically it will show 3 age detection image in one figure. Let's deactivate this because I don't want to show this image this time, so just comment it. If I run it now, so I've got 3 images side by side. As you can see, there are subtle change in different edge detection techniques. For instance, in pre-weight edge detection, you can see it has detected the least amount of edges, and the canny edge detection has detected the most amount of edges, and Sobel is in between. There is a difference between these two, Sobel image edge detection and pre-weight image edge detection, and the canny. Canny is different than these two because canny's masking work into some canny's masking work little bit different way. Canny edge detection technique differ from the first two. The way is, if you can just Google it. So these are the processes. You can see the canny edge detection happen rather than the one-time kernel implementation, like a vertical kernel and horizontal kernel implementation. It goes through few of these steps. First, start with smoothing with Gaussian filter, then gradient calculation, non-maxima separation, and thresholding. I'll take a break. I will close this tutorial today, and the next tutorial I will discuss more about canny edge detection and all these processes. Thank you for watching this video. See you next time. Welcome back to the edge detection tutorial second part. In this part I'm going to do the edge detection and color separation. Let's do some recap first. Last session, which was the first session of the edge detection, I did the image opening technique. So basically for this opening, use the imread command and the image name, as long as the image is in same working directory as the program is saved in. So this command will work, and obviously, as I mentioned, that this code I'm showing here is guaranteed to work in MATLAB 2019, but the earlier version of MATLAB is not guaranteed to work. Now, for converting an image to grayscale, we use the following code: RGB to gray and the image variable. So here you can see the A. So this A is basically this A variable, which has the image has already opened, and the next part is detecting the edge. For the edge detection, we use this following code, which is the variable name equal edge, and defining the variable B. The process name is a pre-weight. We can write the Sobel, we can write canny, depending on which edge detection technique we really wanted to implement on. Now the next part we did also for detecting line of code by putting percentage before the line. So basically if you put a percentage before the line, the code get deactivated, and you see the color also change. And if you just delete the percent sign, so that make the code active again. Now for plotting two images in one figure, we use this following line of code. So basically at the beginning you write the subplot command, then you specify how many rows and column you want to get. For our image we use that one row and three column image, and the image number here we can see the first one is image number 1 and the second one is image number 2. So in this way you can compare two images side by side, also the number of images as you wish. Now I will proceed to further. Here I have opened the same line of code I just left last time. So we will modify this line of code to color separation of the grayscale image. So here you can see that B equal RGB to gray, which is the grayscale conversion of the color image of hand.png. Now if we just write here, then put some text on just for visualization. Title color separation. Now go back to the code. For the color separation, at the beginning we need to assign a variable name. So as I have used the name A, B, C, D, let's use the name G here. So we do color separation of B, bracket, so here in this line of code, if I wrote number 3 in the third part of the bracket, so if the 3 indicate the color red, no sorry, the 3 indicate the color blue, let's comment it. So if I just show this G, let's copy and paste it. Let's run this section of code. Okay, we see some error. Well, let's not use this line of code. We change this line of code to just a different method. R G B equal I am split unsplit A semicolon semicolon subplot 2 to 1, I'm sure R, which is the red component, give it a title, red channel, bracket, how about running the code now. So we can see that our red channel image is showing in the subplot, but it's just plot number 1. So we will compare 3 color side by side. So let's just copy this line of code, copy, subplot 2 to 2, this time is the green G. This G we are finding because we have already assigned in the code here R, G and B. So the first one is the red, green and blue. So I'm sure G, give it a different name, green channel. Now the third one, we copy this line of code, the third one, three, B for blue, changing the name, blue channel. So if we just select this line of code and just run the section, this section, run section, here we can see we got these 3 image, red channel, green channel and blue channel, they coming side by side. So let's just analyze. You see this red, green and red channel, green channel and blue channel, each of them has got 255 pixel, but the pixel intensity is different in their each color map. So basically there is 3-dimensional array. When these 3 image overlap, they produce a color image of this image. Let's clear the whole code from yesterday. If we just run the whole thing, so we got our clean code. Let's just save it as a different file, save as that tutorial part 2. Okay, now let's combine the 3 color image. So previously we separated 3 color image, now we will combine them just to show that it can produce the original image. So again, text, title, code, so I give it a different variable name. So in this case I'll say p equal, the command is cat, cat. Cat is for combining. Cat 3 channel, so 3 red, green and blue 3 channel. So the name we have previously assigned here is that red, green, blue RGB. So we write the same thing, just copy from inside. Semicolon. Subplot many of the code here I'm just copying and pasting because I want to practice myself. Also I can recommend you to do modular approach in programming. Modular approach in programming is that you write line of code and you can reuse it in number of times. I've been told this is a standard practice in programming. So modify this code. So got 2 row 2 4 4. I am show p combine channel title combine channel. What will happen now? So here you can see this is our combined channel image. We got the red channel, green channel, blue channel and the combined channel. So overlapping these 3 frames can produce this image. Now I will do individual edge detection. So give it a highlight again, text, title. Individual color component edge detection code. If I just write for the red color component, red edge RE equal edge bracket R semicolon comment red edge detection subplot this one, copy paste, changing the name, detection, so if we just run the section of the code, so selecting run section, okay, now copy the whole thingy, then changing the name, this time is green edge G green edge, subplot number 2 GE, so which is green edge, title green channel edge detection, let's select all these, run section. Yes, it's doing. Control V. This time blue channel edge detection, BE, edge is blue, comment is blue, edge detection, subplot number 3. So I'm sure BE title blue channel edge detection. Now one combined channel, this P, which is the combined of all the 3 frames, so I want to do it side by side just for a comparison. So Control V, this time it is P is the combined image, so PE edge. Want to do the P edge detection, subplotting number is 4, just check, so 3 4. So PE combined channel, title BINE, combined channel edge detection. Just select this line of code. Run section. Okay, we got an error. Okay, so this combined channel, we need to deactivate this line of code. Selecting, commenting. Now this is deactivated. Oh. Okay, it's giving the error, that error using edge, expected input number 1i to be 2-dimensional. Okay, so this PE image has got 3-dimensional array, which is red, green and blue array. So we want to make it 1-dimensional, which is the grayscale image. So basically this is the same as that B, so we just change the name to PE2, changing the variable B, which is our grayscale image, PE combined channel image. Okay, let's play it now. Run section. Okay, here we get that 3 color channel image. If we can just zoom in, we can see there are some subtle changes. Basically here in this finger we see different pixels. Like at the top of the finger we don't see any pixel here on the green color channel, and the blue color channel we can distinguish 1 2 3 4 5. We can distinguish all the fingers. So basically this is the comparison, and you can see different color channel. How about let's change the image. So we got the hand PNG, we change it to the ski image, ski.png, this image ski.png. So just changing the name and using the same code, ski.png. Okay, let's run this code. Okay, now I'm sure A. Okay, so I've got the color image, grayscale image, then combining all the edges. So here we can see the edge detection of 3 different color component edges. though it is not possible to distinguish between different color component edge detection at this moment, but different pixel intensity can be seen in other picture. Let's see some picture with different contrast. How about the road PNG? Changing the name. Road okay, so this image, you can see the color image, grayscale image. So red channel edge detection, green channel edge detection, so all of the edge detection are canny edge detection. About this image rb.png, yeah, that's it. This is better image. Okay, that's a JPG image. JPG. Okay, so this is the main image. It has got three pure color component. One is red, green and blue, that has been converted to the grayscale image. So this image has got three dimension, red array, green array and blue array, and this gray image has got only one dimension. Here is the color component separation. So basically we've got the pure red, so pure red in red channel. Here we see that only pure red is detected and has been put so here the only pure red channel edge is detected, and here in green color channel image you can see only the green color is detected. So here is the green color and this color edge is detected here, and blue channel edge detection, so this part is detected, which is blue, this part. How about showing it in one frame, all the color component, different color component. Okay, here we can see there's two different image plane is overlapping each other. So basically if I can just deactivate this line of code, which is the edge detection code of different color channel, so comment it, that will deactivate it and it will change the color to green. So now only this line of code is activated. If we run the whole code, that give us this picture. So red channel, green channel, blue channel and combined channel. Now if we just activate this line of code now, uncomment, this will activate this line of code, and running the whole thing here, you will notice that only edge will be detected in this color channel in red component here, and blue edge will be detected here, green channel edge will be detected here, and combined channel edge will be detected here. So if we just run this code now, here we go. So this way we can detect the edge of grayscale image, different color component image, also the combined color component image. The combined color component image edge detection is basically grayscale image edge detection, because with this current line of code we are using, it can't detect edge in the color image. For that there is a different code. Let's talk about some upcoming project in this channel. Currently I am developing a computer vision based robotic guidance system. Here basically, as you can see, this car I will be using. So basically I have generated this card in 3D parts, then I used Raspberry Pi with onboard camera. So basically the camera will see things whatever is in front of it. So the image will come from the camera, it sees things whatever in front of it, then the image is processed, image is segmented image will be post processed before it is sent to the feature extraction part in the code. This code I will be using Python programming language with OpenCV. OpenCV is a open source computer vision algorithm for Python. It also can be used for C, also in MATLAB programming language as well. It was developed by Intel. So I'll be using OpenCV to extract the image and recognizing the object, recognizing the obstacles whatever is in front of it. So the robot will be programmed to go towards its target and avoiding these obstacles. Basically I'm designing a robot, a general purpose robot, which can be utilized in pick and place robotics, also search and rescue robotics. I will be publishing this coursework in next 2 weeks, so stay with me. Hello and welcome to another video of Indus Education. In this video I will be exploring image color separation technique. Basically one image has got 3 color channel, red, green and blue. So in this video I will be exploring these 3 color component channel exploration. So at the first the color image will be open, then with this following command a equal I am red and the image name, then the image is converted to grayscale image with RGB to gray command, then the image is converted to the RGB arm split A command. So basically the image is converted to the 3 color channel, red, green and blue, and in this image it is showing the red color component. And the next one, the same code, but I am show G, so it's showing the G component, which is the green component of the color image. So this is the green component of the color image. And the third one is that blue B, I am show B with the same arm split command. So in this picture it is here basically this color channel, only the blue component of the color channel is been shown. So what is blue here? Bear in mind that these are the blue components, so it is white, pure white, and this red component is absent from the image, and also the green component, which is basically here, so it is showing black as well. So only the blue color channel is shown in the in this channel, and same goes for the red, green and blue. And the next one, we just made some subtle comparison. We can see that the red color channel only red is shown highlighted as the white, and green color channel only green is shown. This part is basically green, but here also there is some green existent in the image array, and obviously in this part as well you can see only the blue color component has been shown. Then this command p equal cat 3 RGB is used to combining those 3 color channel to one. So basically with this command it has been combined in one color channel, so it gives the full color picture, and it then the I am show p shows the image. So now, as you can see, I have already opened the file for you. So here is the code. A equal imread parrot.png. It is showing me the parrot picture, and I am show A. Basically, this is the code for showing the image. Then it converting to the RGB to gray in A image. Let's change the picture to a different picture just to see the what happening behind. If I change this picture to the hand.png, so basically this picture I want to open, and I want to put through the same code I have just demonstrated to you. So hand.png. So if we run this code, so we will modify this line of code to color separation of the grayscale image. So here you can see that B equal RGB to gray, which is the grayscale conversion of the color image of hand.png. Now if we just write here, then put some text on just for visualization. Title, color separation. Now go back to the code. For the color separation, at the beginning we need to assign a variable name. So as I have used the name A, B, C, D, let's use the name G here. So we do color separation of B, bracket, so here in this line of code, if I wrote number 3 in the third part of the bracket, so if the 3 indicate the color red, no sorry, the 3 indicate the color blue, let's comment it. So if I just show this G, let's copy and paste it. Let's run this section of code. Okay, we see some error. Well, let's not use this line of code. We change this line of code to just a different method. R G B equal I am SPLIT unsplit A semicolon semicolon subplot 2 to 1 I'm sure R, which is the red component, give it a title. Red channel, bracket, how about running the code now. So we can see that our red channel image is showing in the subplot, but it's just plot number 1. So we will compare 3 color side by side. So let's just copy this line of code, copy, subplot 2 to 2, 2, this time is the green G. This G we are finding because we have already assigned in the code here R, G and B. So the first one is the red, green and blue. So I'm sure G, give it a different name, green channel. Now the third one, we copy this line of code, the third one, B, B for blue, changing the name, blue channel. So if we just select this line of code and just run the section, this section, run section, here we can see we got these 3 image, red channel, green channel and blue channel, they coming side by side. So let's just analyze. You see this red, green and red channel, green channel and blue channel, each of them has got 255 pixel, but the pixel intensity is different in their each color map. So basically there is 3-dimensional array. When these 3 image overlap, they produce a color image of this image. Let's clear the whole code from yesterday. If we just run the whole thing, so we got our clean code. Let's just save it as a different file, save as Start tutorial part 2. Okay, now let's combine the 3 color image. So previously we separated 3 color image, now we will combine them just to show that it can produce the original image. So again, text, title, code. So I give it a different variable name. So in this case I'll say p equal, the command is cat. cat is for combining. Cat 3 channel, so 3 red, green and blue 3 channel. So the name we have previously assigned here is that red, green, blue RGB. So we write the same thing, just copy from inside. Semicolon. Subplot. Many of the code here I'm just copying and pasting because I want to practice myself. Also I can recommend you to do modular approach in programming. Modular approach in programming is that you write line of code and you can reuse it in number of times. I've been told this is a standard practice in programming. So modify this code. So got 2 row 2 4 4. I am sure P combine channel title combine channel. What will happen now? So here you can see this is our combined channel image. We got the red channel, green channel, blue. Hello and welcome to another video of English Education. Today's topic is discussing about the image noise removal technique in MATLAB 2019B. Now let's talk about the noise. What is noise and how it occurs? Digital images are prone to various types of noise. Noise is the result of errors in image acquisition process that result in pixel value that do not reflect the true intensities of the real scene. There are several ways this can happen. For instance, if the image is scanned from a photograph made on film, the film grain is a source of noise. Noise can also be the result of damage to the film or be introduced by the scanner itself. If the image is acquired directly in a digital format, the mechanism for gathering the data, such as a CCD detector, which is the camera sensor, can introduce noise itself. Electronic transmission of image data can introduce noise as well. Let's start a new MATLAB file. So new live script. We open the image first, which I have already saved in the working directory here. So A equal read that's the coin .jpg upstroke showing the image. If we run the file, we see our image on right hand side. Now just comment it. Now we convert the image to RGB to grayscale. So B equal RGB to gray image file A, f-stop. Now open this RGB to gray image, which is imshow B, this is our RGB to grayscale image conversion. Now let's add some noise. There are different kind of noise. For this tutorial we will be using salt and pepper noise. So another variable C equal imnoise bracket B comma stop salt and pepper. Intensity level 0.7, apostrophe imshow C, run the code. Here we can see this is our noise, this is our image before the noise addition, and this image is the after the noise addition. So now we remove the noise with average filter. Just comment grayscale converted. Now next variable D filter 2, this is the command for noise removal. F special and the bracket stop average comma 3 color channel. Though the image has already converted to the grayscale image, it still has got the 3 color component in that image. That's why we have to put 3 color channel in the code. Then comma variable C, (255), which is a 8-bit image. Figure imshow D, so if we run the code now, it takes some time. As you can see, this is the image
before the noise removal, and this is the image at the bottom after the noise removal. We can see that the noise has been removed, but it is not eradicated 100%. There are still, we can say, about 30 or 40% noise prevail. So the conclusion is that noise removal technique can't take back the image 100% to the pre-noise image. Now we can verify our code by running some other image file as well. So if we just type hand.jpg, which is another image file, has already been restored in the working directory. Running this file, so we see the similar result. Then another image, this image here, parrot.png, running the code, we see the image after the noise addition, and this is the image after the noise removal. Now I will conclude the tutorial today here. Hopefully you like it. If you like this video, please like, comment and subscribe. Thanks for watching this. I will see you next time. Thank you very much. Welcome back. Today's MATLAB session is working with MATLAB image signal to noise ratio. What is it exactly and why is it important? Now, as a consumer perspective, if you want to buy a camera, there are three things you should take care of. The first thing is the aperture quality, how good is the lens and the camera component overall, how long you will be able to use it. And the second component is that does it comply with ISO standard. And the third thing you should care of is the shutter speed. Does it produce the frame per second frame you required for your application? Digital image sensitivity described in the terms of threshold level of signal to noise ratio. According to ISO standard, SNR threshold, which is maximum allowable noise in an image for it to be qualified as an excellent image, is maximum 2.5%. So for an image to qualify as an excellent image, the noise should not be more than 2.5% of the image quality, image pixel. To make it acceptable, it need to be below 10%. In today's MATLAB session, we will continue from the previous. Histogram fundamental explained. This tutorial is divided into two parts. At first part, histogram equalization carried out using MATLAB 2019b. At second part, histogram equalization is carried out using Microsoft Excel. For better understanding, histogram comparison of different intensity image is shown using MATLAB. MATLAB 2019b software used different pixel intensity image to compare how the histogram shows in different pixel intensity image. MATLAB 2019b software is used to carry out histogram equalization for image enhancement. As you can see, we open the image in MATLAB 2019b, then we compare the same image in different pixel intensity. The resulting is this. Welcome back. I opened the new MATLAB file. As you can see, to open the image, I used the imread command. So a is the variable, a equal imread dot read dot png semicolon, then
to publish a figure, 1 row 2 column, so 4 row 2 column, and number 1 is the image location. I am show A. I use next subplot 4 column 2 row, and the number 2 will be the IMHist A64. IMHist is the command for showing the histogram visualization of the existing image. Now another image B. Basically these images are same image but in different intensity I have already saved. So the dark red has got the highest intensity, the red.png has got the more lower intensity than the dark red png, and the light red png is more lighter. The pixel intensity is much lighter than the A or B variable. And subsequently I also open the histogram of the subsequent image using the IMHist command, and I use subplot to compare side by side the original image and its histogram. Now once I finish this thing, I'm going to run the code, and okay, I need to do some modification. Basically subplot 427. Now this is the image found by the code. So basically, as you can see, this is the same image, with different pixel intensity, and the histogram is shown on right hand side. Now the histogram image enhancement will be carried out. So A equal this time I'm reading a different image. To enhance this image, I first open this image. So that image name is dark2.png, semicolon, converting to histogram. So B equal histic A. This code, this histic A, will convert the variable A, which is the main image. It will carry on the histogram equalization, and it will enhance the image quality. Now for showing the image side by side, imshow pair A comma B. Method is montage. This montage shows image side by side without overlapping. So montage. The next line, I want to show both the image histogram, not the original image but the histogram of the image, the graph side by side as well. So subplot 1 row 2 column. Column number 1 is the first histogram. IMHist A is the first image without the equalization. Now again subplot the second histogram. So subplot 1 row 2 column. This time the image, the histogram position is 2 in the 1 row 2 column matrix of the image figure. Now IMHist the equalized histogram, which is C, which is B, 64. Now if we run the code now, here we go, we can see the image quality has been improved. Just for better understanding, I do some marking. So before image enhancement procedure outcome, we see the image quality has been improved after the histogram equalization. Now the next video I'm going to carry out the same procedure, but using Microsoft Excel, that will give you proper understanding, more total understanding in the concept of histogram equalization. I would recommend to watch that video. Viewers, if you like this video, please like, comment, subscribe and share, and don't forget to click the bell button. That will keep the update of my channel. Thank you. Welcome back. At the beginning, I will use the Microsoft Excel to explain histogram equalization before using MATLAB to perform histogram equalization to the image. Here is a 8-bit image. It's a low resolution 8-bit image, and at the bottom is the pixel representation of the same image. So you see the corner here is here, so it has got 52 pixel intensity. So the highest pixel intensity would be 255, so the low would be 0. So this is a low resolution pixel. At the center, this is a high resolution pixel, and the pixel value is 144 and 155. So these two pixel is here. Now this pixel intensity has been put in a form of table with the pixel count. So the pixel value 52, there are only one pixel of 52. 55 pixel intensity happens in this table 3 times, so there is 3. 58 happen in this table 2 times, so the pixel count is 2. Same goes for 63, same goes for 62, which is this bit. It happened in here only once, so 62 is 1. So this table contain the pixel value and subsequent pixel count. This pixel value and pixel count has been put in the form of graph. Before I am putting the graph, I would go to the Microsoft Excel calculator I developed for this course. So this is the Microsoft Excel calculator I used to calculate histogram equalization. So basically here you see the 52, 55, 58, this number came from this file. So I just put from low to high resolution and organized them with subsequent pixel count. So the 52 happened 1 pixel count, so the pixel count is here. Same goes for 55, which is here. It happened 3 times, and it happened 3 times here. Then I put this number in the Excel index. Then I use next column. Well, before I move, I made the total sum of the number here. Now at next column, this number is divided by the sum of the whole number, and this number is this number divided by sum of the whole number, which is 2979. Same goes for the third one as well. So basically C6, which is this row, is divided by this row, so we got this number. So this is the formula, PQ divided by SPQ. So PQ is this number, and SPQ is that sum of the all PQ number, which is 2979. Now at next column, we did the cumulative distribution function. Cumulative distribution function is that the function where a number is the sum of that number also the previous number. So the first one, there is no previous number, so there is no sum. So this number and this number is same. The second one goes, if we just click it, so this number is the sum of these two number. Same goes for this number, is the sum of this number. Same goes for this number, sum of this 4 number. Also this number is the sum of this number, this previous number. So use the cumulative distribution function for histogram equalization. Then this number has been multiplied with 7. 7 is the highest bit count, so we multiplied it with 7. This number multiplied by 7 here. Now at the next column, the rounding happened. This decimal number has been rounded to the nearest whole number. If it is more than 0.5, it become 1. Same goes for
2 as well. If it is more than 1.5, it become 2. If it is less than 1.5, it become 1. So the rounding happen, and the formula used is this formula in Microsoft Excel. Now subsequently rounding happen here. This number is the histogram equalization value, the final figure. So previously we got this histogram bit count. Now we got this new histogram bit count. Now to visualize in the form of graph, these blue lines represent our histogram bit count before the equalization, and the red one, which is more even, represent the histogram pre-equalization. So as you can see, the blue one is very randomized nature, but the orange one, which is after the histogram equalization, the bit count in a systematic manner. The resultant image before this image, and this is the equalized image. So the histogram equalization increase the contrast of the subsequent of the neighboring pixel. So you can see here the contrast there is even contrast in the pixel values, but in the blue lines the pixel contrast is random, which is the result of this image, and after the histogram equalization we found this image. Now I will jump to the MATLAB program to visualize this thing in MATLAB. The original image and its histogram. Now once I finish this thing, I'm going to run the code, and okay, I need to do some modification. Basically subplot 427. Now this is the image found by the code. So basically, as you can see, this is the same image, with different pixel intensity, and the histogram is shown on right hand side. Now the histogram image enhancement will be carried out. So A equal this time I'm reading a different image. To enhance this image, I first open this image. So that image name is dark2.png. Semicolon. Converting to histogram. So B equal histic A. This code, this histic A, will convert the variable A, which is the main image. It will carry on the histogram equalization, and it will enhance the image quality. Now for showing the image side by side, image pair A comma B. Method is montage. This montage shows image side by side without overlapping. So montage. The next line, I want to show both the image histogram, not the original image, but the histogram of the image, the graph, side by side as well. So subplot 1 row 2 column. Column number 1 is the first histogram. I am hist A is the first image without the equalization. Now again subplot the second histogram. So subplot 1 row 2 column. This time the image, the histogram position is 2 in the 1 row 2 column matrix of the image figure. Now I'm hist the equalized histogram, which is C, which is B,
64. Now if we run the code now, here we go, we can see the image quality has been improved. Just for better understanding, I do some marking. So before image enhancement procedure outcome, we see the image quality has been improved after the histogram equalization. Now the next video. Viewers, if you like this video, please like, comment, subscribe and share, and don't forget to click the bell button. That will keep the update of my channel. Thank you. The same line of code I used both in Windows PC as well as in Raspberry Pi 4 for video file histogram equalization. The resulting output is the dark image become visible.
Long time ago, I had a friend named Diane.
I used Windows PC, Raspberry Pi 4 and MATLAB for converting color image to grayscale. Then from grayscale histogram equalization is done.
Long time ago, I had a friend named Diana. And something really bad happened to her.
Hello and welcome to another presentation of Indies Education. In today's presentation, I'm going to demonstrate how you can use pixel intensity to make dark video more lighter. So you can make more presence of the light in the video quality. In this way, you can make the horror movie less scary. For this thing, basically I use the histogram equalization. I use Windows computer with Python OpenCV in Spider 3 IDE. Also I use the Spider 3 IDE in Raspberry Pi computer as well. And then at the end I'm going to show the basic histogram equalization using the MATLAB.
This line of code in Python OpenCV I have used. You can find the detailed code in the description link below. The code begins with line 8 and 9, where I imported two libraries, CV2 for OpenCV and sleep from time. Line 13 captured the video frame from the MP4 file I already placed in Python working directory. If the video frame received from the MP4 file, line 20 initiated in a while loop. At line 23, the video file frame is resized to 640 by 640 pixel. Line 25, RGB image frame is converted to grayscale image. At 27, grayscale image frame is histogram equalized. Line 31 show the frame after equalization. Line 32 shows the color frame. The right hand side you can see all the hardwares implemented in this video. I have used Raspberry Pi 4, Windows PC with OpenCV Python, also MATLAB 2019B as well. Next few minutes you will see my OpenCV histogram equalization outcome with Raspberry Pi as well as Windows PC. Before I will show the histogram equalization.
Did we wake you?
What?
Long time ago, I had a friend named Diana. And something really bad happened to her.
Everyone is afraid of the dark. That's what she feeds on.
Now the histogram image enhancement will be carried out. So A equal, this time I'm reading a different image. To enhance this image, I first open this image. So that image name is dark2.png. Semicolon. Converting to histogram. So B equal histic A. This code, this histic A, will convert the variable A, which is the main image. It will enhance, it will carry on the histogram equalization, and it will enhance the image quality. Now for showing the image side by side, image pair, A comma B, method is montage. This montage shows image side by side without overlapping. So montage. The next line, I want to show both the image histogram, not the original image but the histogram of the image, the graph side by side as well. So subplot, one row, two column. Column number 1 is the first histogram. I am hist A is the first image without the equalization. Now again subplot the second histogram. So subplot, one row, two column. This time the image, the histogram position is 2 in the one row two column matrix of the image figure. Now I'm hist the equalized histogram, which is C, which is B, 64. Now if we run the code now, here we go, we can see. Dear viewers, if you like this video, please press the like button and subscribe. Also let me know your opinion by commenting. Thanks for watching. I will see you next time. Thank you. And how I have utilized the virtual robotics for developing this robot. So at the beginning I will introduce my Raspberry Pi 4 robot. As you can see, this is my Raspberry Pi 4 robot. It has got a onboard webcam. With this webcam it sees whatever is in front of it. Then it passes that information to the Raspberry Pi 4 computer. From that Raspberry Pi 4 computer, then it decides how to move this 4 DC motor on board, and it has got the motor controller for doing that job. So motor controller works in between the Raspberry Pi 4 computer and the DC motor. Now I have integrated virtual robotics for developing this project. The way virtual robotics, you don't have to acquire any hardware physically, but you still can code your robot. You still can make a program which will work for your robot. In this way you can save your cost. Also the main obstacle of going to robotics, I would say there are three things you need to require to build a robot. The first thing is you need the right hardware, the second thing is you need right software, and the third thing is you need your ability to code. Now acquiring the right hardware is expensive, and you never know that whether you will ever be able to code it before acquiring the hardware. So for instance, you buy some expensive hardware, then you can't use it because of your ability of coding or other problem. So in this case the virtual robotics comes to play. In virtual robotics you build your parts with computer aided dimension with different CAD software. For me, I have used Inventor, Autodesk Inventor for part building. Then you import those parts to VREP robot simulation. As you can see the background, you can see the VREP robot simulation is going on. Basically I have built my whole robot in VREP simulation, and it has got all the, as you can see, it has got all the physical hardware and software in it. In this way
Then I have developed the Python code to operate the virtual robot. Once my virtual robot is working, once I am pretty sure that, confident that I'll be able to execute it in Raspberry Pi 4 robot, then I have acquired my physical parts. Though the irony is, these parts are not expensive. This is just a uh, usual STEM robot buggy, but imagine there are many more expensive robots. For instance, I have got my other video with Kuka U-boat, which is a prototyping robotic platform, Kuka U-boat, but it cost nearly about 30,000 pounds. So imagine you acquire some hardware with 30,000 pounds, then you can't program it. So what is the point? Rather, you get the virtual hardware, then you program it, then you make it in work. Now this is my virtual robot. As you can see on the background, I have made it work. So in my virtual robot platform, as you can see, there is an arena I have created, and I have transferred the code to my virtual robot. That virtual robot has got a red color ball in front of it. That is a tracking ball, and it is a moving object. So that ball is a target, and it moves over the time. The robot job is to track that ball, to follow that ball. At the same time, it keeps the minimum distance from that ball. By the way, I have included the video file you can see at the background, and you also can download this project from my website. Now, get some explanation is that the video file, you can see on the screen that it is tracking a red color ball, and that ball is a moving object. So the robot follows that ball. At the same time, it keep a minimum distance from that ball. As you can see, the background, the image is showing it is measuring the distance from that ball as well. The file is included, and I'm also planning some Google Hangout sessions, so just give a shout if you are interested about my project. Next week I'm going to publish the actual code with working Raspberry Pi 4 project. Work is that also open for any kind of help I can do to your STEM project. Also, dear viewers, if you like my project, don't forget to subscribe, comment and share. Thank you for watching. I will see you next time. Thank you. Even the car on further way is detected. As soon as the vehicle appears at the horizon, it is detected and a rectangular blob is created. Intel OpenVINO graphic user interface also very interactive. It helps to visualize the text, and the way it is easy to understand. This video is shot during the COVID-19 lockdown, so you can see there is not much traffic on the road. There is two negative things about this code. Number one, it misses some of the vehicle. As you can see, some of the vehicle is not clearly marked, so that means that the code is not detecting some of the vehicle. The second is the rectangular blobs are made of very thin line, which is sometimes difficult to see. But regardless, if you use your code as a embedded code, the visualization is not really matter. As long as it is detected, the machine can operate the expected operation. The hardware used are Raspberry Pi 4 with Intel Movidius neural computing stick. The rest of this tutorial will explain the detailed Python code with Raspberry Pi 4 and the other hardware used. Hello and welcome to another presentation of Indis Education. In this presentation, I'm going to discuss computer vision based AI implementation in Raspberry Pi 4. I will discuss my custom made Raspberry Pi image and Intel Movidius neural network accelerator use. Now, Raspberry Pi 4 is the best single board computer in market for beginner level machine vision tasks. Computer vision based AI implementation project required a high level of computational power for a steady level of frame rate in machine learning. Even the latest Raspberry Pi 4 Broadcom ARM system on chip is slow to perform the desired outcome. To bridge this gap, Intel Movidius neural computing stick accelerator can be used. Now the problem comes because Raspbian is an open source platform. Installing required Intel library is time consuming. Keeping this in mind, I have prepared an out-of-the-box Raspbian OpenCV image. Just to clarify more, this is for Raspberry Pi 4 only and ready for Intel Movidia's deployment. This is a paid for download and the link is provided at the description. Now I will discuss the different feature of the code. For this, I have opened the link provided at the description box below. Now let's talk about the OpenVINO demo vehicle detection code. The link in my web page, this link provides cafe vehicle detection code. It is in the form of .xml and .bin file. These files are the intermediate representation IR of the actual vehicle detection cafe code. If you just click this, you will get these two set of file which you need to download. To download this, you use wget command in Raspberry Pi CMD. Now these are the code I have used myself to use these IR file. My detailed code for Raspberry Pi 4 started with importing all the libraries. Only 3 libraries had been imported. Now in this part, the IR intermediate representation files are downloaded from the top link. They are integrated to my code with cv2.dnn.readnet command. Here you can see the 2 file has been indicated. Now the next part of the code, the vision processing unit need to be defined. It could be Movidia's computing sticks, NCS, Windows computer or FPGA, but in our case we used NCS, which is defined as myriad. So net.set preferable target cv2.dnn target myriad. So the deep neural network module will utilize this myriad vision processing unit, which is inside the Movidia's computing stick. The next, we open the video file. It can be from the real-time webcam, but in my case I have used the pre-recorded video file. I have recorded the video file from my mobile phone because I do not have any good quality webcam. So as the frame is received from the camera, cap.read initiates the frame for processing. This line cv2.dnn blob from image put the frame to the myriad VPN for detailed analyzing and machine learning object detection implementation. For this, it initiates cv2.cv8u, which is 8-bit image input. Now in this part of the code, net.set input blob, frame is the input, frame is the output, 8-bit image analyzing, a confidence generated from the code. Finally, the rectangular blob is drawn with xmin, ymin, xmax and ymax coordination. If the confidence level is more than 2, blobs are marked with rectangular line. Graphic user interface text are created and visualized. In this part of the code is generated with the graphic user interface text and the blob visualization of the vehicle detection, and some sorts of interrupts is implemented in this line of code for emergency code shutdown. Thank you for watching this video. If you like this video, please like, comment, subscribe and share. I will see you next time. Thank you very much.
Good morning, ladies and gentlemen. Welcome to my project presentation of Raspberry Pi based computer vision robot. In this project, I have developed a computer vision robot using Raspberry Pi 4. Before getting details to my project, I would like to present you some of the project background, the historical background of robotics in general. 1478, Leonardo da Vinci demonstrated his self-propelled cart concept, where he used a spring stored potential energy. When the spring was released, the kinetic energy created from the spring potential energy would move a robotic buggy. University of Berkshire in 1958 came up with the tractor B250, driverless tractor. 1969, Auto Truck of Hampshire demonstrated their buried wire-guided Ferguson 165 tractor. New Holland of Netherlands demonstrated their GPS-guided autonomous tractor in 1995. As of 2018, the market was 45 billion worth. In 2020, there is 240 billion pound market potential. My robotic project is just a small part of this bigger picture. I have used computer vision sensor, webcam, and this is my only and one sensor in my robot. So here I provided some of the justification that why did I use the webcam rather than using its counterpart of reflection based sensor like IR sensors, sonar sensors, lidar sensors. The reason I used computer vision sensor is that it provides superior feedback through image processing. Then reflection based sensors contains higher number of information. Basically, in an image there is all the information, but it's just only matter of fact that how to extract those information and utilize them. Computer vision sensors has got many others positive sides, including it is cheaper. My vision sensor cost only £9, whereas its counterpart of lidar sensors, the cheapest one, is £70 to procure. It has got very low power consumption. I used only 12-volt battery, and it has got no moving parts, so it's less vulnerable for accident or any other kind of damage. Low power consumption, as I said earlier. This project is aimed at developing a computer vision based Raspberry Pi 4 robot. To accomplish this project aim, the following objective I have visualized in the form of this flow chart. I started building the cat parts at first. I have designed all the cat parts myself using Autodesk Inventor software. Then all the cat parts has converted to STL file format and transferred to the VRAP robot simulation software. Then on the simulation software, I executed my developed algorithm in Python programming language, where the virtual robot has got its own camera. Virtual robot with all the cat parts, it has got its own camera in virtual arena, and with the developed Python algorithm, it is possible to simulate the robot in virtual environment. When I have simulated my robot and all the bugs has been eliminated, and that means that I'm confident enough that it would work in real life robot, I transferred the code, little bit customization to the physical robot, and the same code, same webcam, but it is physical webcam, similar kind of feedback system compared to the virtual machines. Process chronology, I would like to discuss little bit more about the process I have already discussed. So these are the process of building the cat parts and the components used for this project. So the robotic buggy has got 4 wheels, 4 DC 6-volt DC motor, and Raspberry Pi 4 computer, and the motor controller. As you can see, the motor controller here, buck converter, 12-volt battery, and the webcam. I designed them all in Autodesk Inventor in CAD parts, and I converted them to STL file format, then transfer to the virtual robotics. Now the detection, next part in the virtual robotics, the following algorithm I have to develop: detection, recognition, global coordinates, and distance measurement. And when the program has been matured, I transfer them to the physical real life hardware. Background theory, to get my project working, I have to research a lot, and there are over 40 different academic sources I have utilized to come up with my project idea. So this is one of them I would like to discuss to you. So this idea was proposed by Lee and Hang, Taiwanese scientists, on their paper in 2013. So they used 3 input, 3 sensor: laser rangefinder, sonar sensors, aerial robot, and aerial robot. These are the sensors. They put input data, and the output is utilized by the ground station, and the hardware is the robot. It connects to the ground station. Station command the robot to move whatever to do with the feedback information it is getting from the 3 sensors. Next one is proposed by Wang and Silva, again another Taiwanese scientist, in 2009 on the paper. They proposed to use the Q-learning, reinforced learning, machine learning, for their robot to learn itself from its own mistake. So in this way, the robot, they would program the minimal program. They would give minimal instruction for the robot for problem solving, and the robot would utilize the Q-learning algorithm, reinforced learning algorithm, to learn itself from its own mistakes. Edge detection localization background theory is proposed by Yang, another Taiwanese scientist. He proposed that how to analyze the camera feedback information, camera analysis, how to do image processing for robotic movement to get the desired feature from that image. So it started with the input frame, grayscale. Then the grayscale image has been Gaussian blurred. After that, canny edge detection happened. Then object segmentation, half transformation, and output frame resulting the desired feature has been marked for the robot to analyze that feature. Proposed solutions: analyzing all the academic sources, I have come up with my own solution for developing the algorithms. So I start with image acquisition from the webcam, then 3 stages of image processing happen: image pre-processing, main image segmentation, segmented image post-processing. Once the image has been post-processed, one image is ready for, once all the unnecessary things has been deducted from that image, then the image has been put through the feature extraction algorithm, feature based classification. It has been classified what kind of object it is, application specific feature extraction. Then based on the robotic application, that feature has been utilized with other algorithms. Hardware selection, I have compared few of the single board computer in the market. So my justification was cost, efficiency, easy to program, on that easy to program, and frame rate per second for visualizing the image. So here are the few comparison against different neural network. So the ResNet, MobileNet, SSD, and SSD ResNet, these are some of the neural networks can work with a single board computer with a low computational power. And now as you see, my choice of hardware is Raspberry Pi 4 because NVIDIA Jetson has got 36 frame per second. Raspberry Pi 3 is 1.4 frame per second, but the closest one to Raspberry Pi 4 has got 16 frame per second. And proposed hardware. I chose Raspberry Pi 4 hardware, and here are some technical specification of Raspberry Pi 4 hardware. It has got quad core A72 system on chip. Then the GPU is Broadcom Video Core VI, which is pretty much customized for machine learning operation, with the networking option of 2.4 gigahertz to 5 gigahertz 802 wireless LAN. The RAM, it has got 4 GB RAM with the Bluetooth interface. So this is very useful for robotic operation in IoT application. Programming interface I would like to discuss. I have used the Python programming language because it has got easy programming API, and also what I found is that with the recent learning trend in the market, in the industry, Python programming language has got a big potential to be a mainstream programming language. Also, it is really easy to code for anyone, easy to find the bugs. I used Spider 3 IDE integrated development environment with the Python programming language. The reason I chose the Spider 3 because Spider 3 has got the similarity with MATLAB programming interface, which I am more comfortable with. This is my VRAP robot simulation screenshot. As you can see, I have transported my robotic buggy to the virtual arena, and there is a virtual robotic cat on top of it on the arena, and the robot buggy can see with the onboard camera. The cat is visualized on the screen here. Now I have connected the VRAP robot simulation engine with the Python programming language, the Spider 3 IDE in node communication. Node communication is where multi-program in same computer or multi-program in multi-computer can communicate with each other and execute one or set of tasks together. So here I have used the IP socket to bridge the communication. So the first one is my IP address, the second one is the socket address, and rest are some API framework. This is the schematics of my motor control circuit. I have used DRV8 4x2 dual bridge PWM motor controller. Basically, I have got 4 motors, so I have paired them. So there is a right side pair and left side pair. So one motor controller unit for the right side, one motor controller unit for left side. As my motor controller is dual bridge, so one controller can control 2 side motor same time with different code and input and output. Program design interface. These are the screenshot of the program I wrote to communicate with the VRAP program, and as you can see, this line of codes has been developed just to simply visualize the virtual camera image. So this is virtual camera. See the robotic dog in virtual environment. The libraries has been imported. So import VRAP, import NumPy, import Matplotlib, import time. These are few of the libraries I have used to visualize the image. Then the buffering happened. The camera buffer has been converted to the still image. Then the continuous looping provide the video image. Motor control interface. Image feature extraction. Here you can see my physical robot, and at the bottom is some of the screenshot of what it is capable to do with the developed algorithm. You can see there's a red object, and the camera can localize where the object is. Here it is showing it is left, here it is showing it is right, and here it is showing it is in center position. With this line of developed code, HSB frame, CB to color, converting BGR to HSB, so RGB to HSB frame. Then there is a thresholding applied, low threshold, low red threshold, and high red threshold. So in between the low and high, the spectrum of the color coded image will only be accepted for the code, and other image feature is eliminated from the information. Then the marking happen. It put a marking at the center, and it also measure the distance from the camera, the object.
Next line of code I have developed to measure the distance. So the first one was the location, left, right or center position, and this one is for the distance measurement, so the robot can see the object in front of it, then it can analyze that it is in right location or left location or it in center position in compared to the screen resolution. Then it drew a bounding box, and changing the bounding box with the variable speed and distance, it measured the distance of the object from the robot to the bounding box. In this way I have simulated what the robot is capable of. So I have drawn a wall with a few of the bounding box painted on the wall. There is a red ball in front of it. This red ball is a moving object, so my robot would track this red ball and navigate against these red and white blocks. So as you can see here, it has tracked and it has detected the blocks, and it also detected the red blocks, and it has detected the location of the red blocks. Same time it measured the distance of the red ball and the wall as well. Following algorithm happened. So the program initiated, then the object location has been analyzed. If the location is less than 1 and left, right pair will get activated. If the location is less than 1 feet and right, then the left pair will get activated for the robot to correct itself and keep the target in center position. Location greater than 1 and center, both pair wheel is clockwise. Location less than 1, left pair wheel is anti-clockwise. So this is a sharp turn from left and right. Then the end of the code program terminated, and reset and end happen. So those are the algorithms. Step by step algorithm has been developed with Python programming language, again with Spider 3 IGE. Convolutional neural network, artificial intelligence, has been applied to recognize different objects. So here you can see I'm holding a mobile phone, and my robot can recognize it's a mobile phone. It is me myself. It can see, it can detect and show that a person has been detected. Project outcome: the robotic guidance system developed is able to identify targets and navigate to it. It can identify the obstacles and navigate against it. When it is following the target, it keeps the minimum distance from the target just to avoid the collision. It follows a red blob and keep 1 feet distance away. It navigates against the wall. Here I have measured the distance of that red blob in real life with the measurement tape, and I have also measured with the camera with the developed algorithm. So as you can see, the camera is showing the visualizing the image, and it is showing the distance of the image and the location. So the location it has detected is in central position, and the distance is 1.3 feet, whereas in real life it is 1 feet. I took a number of samples in this way and plotted a graph comparing the two value, the real life measured value and the camera measured value. As you can see, it is almost perfect. There are very slightly less error, but that also can be eliminated with higher level of signal processing. I used Microsoft Project for planning my project tasks, keeping track the progress, also any features I need to take special care of. So as here you can see, I have initiated the project in 5 stages. So I started with initialization, planning, control, execution, closeout. So there are 5 phases. In 2 months time I worked in this tight schedule. There are some time deviation of the project highlighted in red, that I have to be repurposed the project task and reschedule it. So here it is highlighted in red. What I found is that Microsoft Project is really useful for planning a project. You can visualize all the project tasks with the interactive Gantt chart, and it has got an easy programming interface where you can go and change things as you need for the project to progress. In this project, the outcome I have got is field of advanced robotic has been explored, Python robotic capability explored, robotic hardware integration practiced, real life entrepreneurship option also explored. I'm also looking to maybe one day I'm also looking to commercialize my robot project based on how I'm gonna make it industry ready. Project conclusion, I would like to say the project aim and objective have been accomplished. A computer vision based robotic guidance system have been designed and deployed. Its performance have been analyzed and documented. Future works include lots of signal processing, make it perfect, make it deployable for real life industry. Thanks for attending. Any question?